In a previous video, you learned how to detect whether a ball was hitting the edge of the screen, and if it was, to reset its position to somewhere else. And you can use that to create screen wrapping like this. If the ball hits the bottom of the screen, you reset its position to the top. In this video, I'm going to show you how to react in a different way to hitting the bottom of the screen. Instead of resetting the position, we're going to change the ball's motion, so we're going to have it bounce off the bottom of the screen. Let's decide which parts of the code we'll need to change before we decide how to change them. So this is the line of code that's testing if the ball is past the bottom of the screen, because past the bottom is its vertical position, so I know I need to look at the y-coordinate, and the y-coordinate to the bottom of the screen is 800, so this is like asking, is my vertical position past 800? So I still want to ask this question, because I still want to do something when I hit the bottom of the screen, except now I want to change what my reaction is. So I don't want to set the position back to 0. Instead, I want to change the ball's speed or direction. Well, I guess you think about it probably as direction. So I'll change the ball direction. How do we do this? Well, that's part of what we're going to talk about right now. Let's think about what inside this program controls the direction the ball moves. Right now, this is the line of code that moves the ball. So if I add 6 pixels every time, I know it's moving down pretty quickly. If I add 1 pixel every time, it's still moving down, but now it's moving slower. If I was going to change this to -2, now I'm subtracting 1 from the y-coordinate every time. So it's moving up instead of down, and it's sort of a medium speed. So I think it's fair to say that whatever number this is describing the vertical speed. So if we want to change the speed to be up or down or faster or slower, we need to be able to change this number. And we can't change this number if it's just a number, so we'll need a variable. I think let's call the variable y_speed, because whatever number is inside this variable is literally describing the y_speed of the object. So just like we did before, let's create a variable up here, y_speed. Let's give it a starting value inside setup. So let's maybe start it out at 2 and see what happens. So when I run the code, y_speed is 2, and so you see that whenever I add the speed into the y position, it's adding 2 pixels to the y-coordinate, so it's moving down. If I was going to change this to -2 as my starting value, and then I run it again, you'd see that it will move up. Okay, so this gives us so I'm going to change it to move down again, and this is going to give us an easy way of changing the ball direction. I can say y_speed equals the opposite of my current y_speed. And let's think about how this makes sense for a minute. If my y_speed right now is 2, then when this line of code runs, first I'll say, what's my y_speed? And the answer is 2. And then I'll take the opposite of that, so it's -2, and then I'll save that -2 as my new y_speed. So as soon as this line runs, it will switch +2 into -2, or if it was -2, it'll switch it to +2. And then the next time we come through the draw loop, this number will be different. Something that's a little bit tricky to wrap your mind around is this line of code doesn't actually draw anything on the screen. It doesn't actually move the ball, because the ball doesn't move unless its y-coordinate changes, and this doesn't change a y-coordinate. So all this is really doing is it's changing the number inside y_speed. But if that's all you did, you wouldn't actually see anything different on the screen. The reason you see something different on the screen is because after you change the number inside y_speed, then later on you use the new number to change the y position. So it's like this is where I test to see should an action happen, but I don't actually perform the action. Instead, I just change numbers inside variables that will mean that the motion that I'm doing all the time actually changes. Let's see what it looks like when we run it. When I hit the bottom of the screen, now it goes the other direction. Go ahead as a self-test and see What would you change in here to make the ball also bounce off the top of the screen? Okay, so I still want to test is it hitting the top of the screen, but then instead of resetting its position, I want to do this exact same thing. I just want to take its current y speed and make it be the opposite so that it's moving in the other direction. Let's change my starting speed to be a little bit faster. Actually, let's make it a lot faster. And now let's see what it looks like. Cool. As a last test, do the following. Let's add a little bit of horizontal motion. And now add 2 more if statements that will make the ball bounce off the left-hand side of the screen and the right-hand side of the screen. Okay, here's an answer. So if I want to test if it's hitting the left-hand side of the screen, that's asking if the x-coordinate is less than 0. And what I want to do when I hit the left-hand side of the screen is change the direction. So I want to change the x speed to be the opposite of the current x speed. But wait a minute, we haven't actually made the x speed variable. Right now, the x speed is always 3, so it's always moving to the right. So we'll have to do the same thing for horizontal motion that we did for vertical motion. We have to create an x speed variable that we use to add to the x coordinate. So we'll do that up here. We'll create x speed. We have to give it a starting value. I'm going to give it a starting value of 8. Here we're using our x speed to change the x position. And here we're saying if we hit the left wall, let's reverse the direction we're going by taking our speed and making it the opposite of its current speed. If I want to hit the right wall, I'll ask if the x coordinate is larger than 800. And then I'll do the same thing. I'll reverse the x speed. Okay, we have all the pieces in place now. Let's see what it looks like when we run it. Wonderful. And now we've got a bouncing ball.